Okay, so in the last video, we discussed a bit about what a limit is, and specifically how a limit is defined and what makes up, like, how would you calculate a limit through a table or a graph. Now, there's some instances in which a limit does not have to exist. And such, there are some very specific cases. Okay, so let's look at our first case. So let's draw a function over here. Okay, so let this be any function. So a limit does not exist. So here's our first case. Let's say this is the graph of f of x. Okay. So here is where the limit does not exist. So if we were to make a chart, let's call this, let's say this is 1. Oh, sorry. So let's say this is 1. So let's call this number 5, and let's make this number, let's make that 1 as well. So as x gets closer from the left, so as x gets closer from the left, so x starts to get higher. So from the left, as x starts to get higher, you see that the function so the function starts to approach 5. So the limit as x approaches 1 from the left, so the limit as x approaches 1 from the left of f of x is equal to 5. So the minus symbol means from the left. Okay, so what about from the right? So limit as x approaches 1 from the right. So from the right, we have, as it starts to get closer and closer and closer from the right, it starts to actually approach 1. So limit of this equals 1. However, these two limits are not in agreement. So these two are not in agreement because from the left it's going to 5, but from the right it's going to 1. That means the limit, the actual limit, the f of x, does not exist. So this is one instance. It does not exist because from the right and from the left approaches different values. So when you have a jump like that, the limit's not going to exist. Okay, so the same applies to a function like this. So whenever there's a jump out of a certain value, you know the limit's not going to exist at that value. So there's another case that the limit does not exist at a value. Okay, so let's look at the graph of f of x equals 1 over x. Okay, so f of x equals 1 over x. So what is the limit what does f of x approach as x approaches 0? Okay, so first, you can see from the graph itself that as x approaches from the right, so as x approaches from the right, it starts to increase without bound. Okay, so as it approaches 0 from the right, it starts to increase without bound, goes towards positive infinity. So it goes toward positive infinity. So it does not actually approach a real number, but just keeps on increasing without bound. Okay, we could see positive infinity. And you could also say it doesn't exist. Okay, so you can either write that positive infinity or just say it doesn't exist because it doesn't actually approach a real number. It's not a real, infinity is not a number. Infinity is just a symbol for something as a function approach increases without bound. This is the symbol we use to symbolize that. So in theory, it doesn't actually approach a real number. It does not exist. Okay, and if we were to take the same limit from the left, start to approach negative infinity, because from the left start to go downward and downward and downward because the x coordinates are negative. So this one also you can say does not exist because infinity is not actually a number. And it even approaches different values. This one from the left decreases without bound, from the right it increases without bound, which is a clear sign. A clear sign that this totally does not exist. There's one last very special case of a limit that does not exist. Let's take the limit x equals 0 of f of x when f of x is equal to sine of 1 over x. So the sine function, you might know, is sort of like an oscillating function, like a wave. And however, this graph it, if you were to graph it, it would look sort of like this. It would look like this. So it would look like this, and then this, and okay, so if you were to graph it on a graphing calculator, it would look like this. So if you were to tally up all the values, okay? If you were to tally up all the values of, like, make a table for different values of x, so such as 2 over pi. So 1 over 2 over pi equals sine of pi over 2, that's 1. 2 over 3 pi, so if you f of 2 over 3 pi would be sine of 3 pi over 2, that's negative 1. And you do the same thing for 2 over 5 pi, sine of 5 pi over 2, because 5 pi over 2 equals 1 over 2 over 5 pi. So sine of 5 pi over 2 is 1. So as you start to go closer and closer to a 0, it starts to switch between 1 and negative 1, and 1 and negative 1, and none and negative 1. Okay, so this one oscillates. Between 1 and negative 1. So there's no clear number it approaches because it will oscillate extremely quickly as it starts to approach 0, 1 and negative 1, 1 and negative 1. Because the values of x are starting to get smaller. Remember, it's 1 over x, not x. So it'll start to oscillate more and more and more quickly, as you can see by the graph. There's nothing really towards 0. It just either 1 or negative 1 at a certain point. So this is another case of a limit not existing. Okay, so we are done.